Hi kids, in this video we'll discuss similarity of triangles, a very important topic. If you can understand the basics and the theorems which are there in this chapter while you're doing exercises, it will be very easy for you. In this video we'll discuss first thing, the condition when two triangles are similar. Second, basic proportionality theorem, that is the Thales theorem. And third, we'll discuss on area of similar triangles. Now let's get started. First thing which I need to clear is the difference between a congruent figure and a similar figure. Now when I'm talking about a congruent figure, okay, I mean in simple term, same shape and same size, which means if you take suppose two isosceles triangle A, B, C and suppose P, Q, R, suppose this is 6 centimeter, this is 6 centimeter, this is 4 centimeter, again this is 6 and this is 4. Now these two triangles have the same shape, okay, they both are isosceles triangle and they have the same size, okay, 6, 6, 4, 6, 6, 4. So we say that triangle ABC is congruent to, this is the sign, okay, triangle PQR. These two figures are superimposable, okay, a mirror image you can say. But when you talk about similar figures, okay, we are talking about figures having same shape, okay, even if the size are not equal, they can be similar, okay. Just look at this. If I draw, suppose you have three circles of different radii, though the radius are different, but these three are similar figures. Similarly, if I draw suppose two equilateral triangle, again suppose this is 4 centimeter, this is 6 centimeter, though the sizes are not same, but these two are similar figures. So I hope what is a congruent figure, what is a similar figure is clear to you, okay. Now let us see, when does two triangles qualify to be called as similar triangles. Now let us see what are the rules to determine whether the two given triangles are similar or not. The first one is angle-angle rule. It says that suppose we have two triangles, suppose A, B, C, and you have suppose P, Q, R, and angle A equals to angle P, angle B is equal to angle Q. If two angles of one triangle is equal to two angles of the other triangle, then we can straight away say that triangle ABC is similar to, this sign denotes is similar to, triangle ABC is similar to triangle. Now A corresponds to the vertex P over here, B corresponds to the vertex Q, so write properly, and C corresponds to R. And no doubt angle C and angle R will be equal, isn't it? Angle C will be equal to angle R. Why? Because the sum of the angles of a triangle is 180 degree. So if these two angles are equal to these two angles, then the third angle has to be equal. Simple. Okay. So the first rule is angle-angle rule. If two angles are equal to two angles of other triangle, okay, and this is a sign of similarity. Now the second rule is side angle side rule, nothing to do with congruency. Look over here. If I take two triangles, suppose, look carefully, A, B, C, this is again P, Q, R, and if I tell you that angle A is equal to angle P, just note it, and the sides containing the equal angle are proportional to each other, which means AB by PQ is equal to AC by PR. If these two conditions are satisfied, then we can say that triangle ABC is similar to triangle PQR. Okay, this is similar to triangle PQR. This is the second rule. Now let us look at the third rule, which says side, side, side rule. Suppose we have a triangle A, B, C. You have another triangle, suppose X, Y, Z. If the three sides of one triangle is proportional to the three sides of other triangle, then these two triangles are similar. Mathematically, I mean, how can I represent mathematically this statement? That AB by suppose XY is equal to BC, suppose YZ is equal to AC by suppose XZ. Then we can say that triangle ABC is similar to triangle, now A corresponds to X, B corresponds to Y, and C corresponds to Z. So X, Y, Z. So these are the three conditions. Now look, one very important thing over here. If the three sides of one triangle is proportional to three sides of other triangle, then these two triangles are similar, which means in other sense, if two triangles are similar, okay, the sides are proportional, which means in this case, if you look carefully, these two triangles are similar. So I can simply say that triangle ABC, look over here, triangle ABC, very important, is similar to triangle PQR by angle property, isn't it? And if they are similar, their sides will be proportional, which means AB corresponds to PQ, AP corresponds to PQ, BC corresponds to QR, and AC corresponds to PR. So whenever you are writing the two triangles are similar, see that the vertex are matching. See, angle A matches with angle P, so I have written A, P over here. Then B matches with Q, so A, B, C, P, Q, R. Don't write like this. Triangle A, B, C is similar to triangle P, R, Q. Because then the vertex are not matching, and then when you are writing AB by PR, BC by RQ, there will be a problem. Okay, because AC by PQ will be incorrect. So whenever you are writing, see that the vertex are matching. Okay. Now let us see the basic proportionality theorem, that is the Thales theorem. Let us see this theorem. If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, then the other two sides, means in this case AB and AC, are divided in the same ratio, which means AD by DB is equal to AE by EC. Okay, that's the theorem. Let us prove this theorem. Look carefully. I'll prove this. Now, I'll just split this into two triangles. See, A, D, E and A, B, C. I need to prove that AD by DB, AD by D somewhere over here, DB by AE by EC is same. Look carefully. Now, these two lines are parallel, which means this angle and this angle will be equal, which means angle D and angle B will be equal in triangle ADE and triangle ABC. Look carefully, angle ADE is equal to angle ABC, corresponding angle. isn't it? Because they are parallel lines, corresponding angles. Similarly, if you see angle E and angle C, which means this angle and this angle will be equal, which means I can write angle AED is equal to angle ACB. Again, the reason is same, corresponding angle. Now, since two angles of this triangle are equal to two angles of the other triangle, then these two triangles are similar, which implies triangle ADE is similar to triangle. Now, A corresponds to A, D corresponds to B, and E corresponds to C. Am I clear? Angle property. Now, if they are similar, we know that the sides are proportional to each other, which means AD by AB, just look carefully, is equal to DE by BC is equal to AE by AC. We know this. Now take this and this. Since all three are equal, so we can say that AD by AB is equal to AE by AC. No doubt in that. Now AB can I write AD by plus AD. I can write AB as AD plus DB. AD plus DB. AE and AC I can write AE plus EC. Look carefully. Okay, just do the reciprocal. So we get AD plus DB by AD is equal to AE plus EC by AE, isn't it? Separate this. So AD by AD will be 1 plus DB by AD is equal to AE by A is again 1 plus EC by AE. 1 cancels, which means DB by AD is equal to EC by AE. We needed to prove AD by DB, AE by EC. Just do the reciprocal. So we get AD by DB is equal to AE by EC. Proved. Okay, that's the theorem. If a line is drawn parallel to one side of the triangle to intersect the other two sides at two distinct points, then the other two sides are divided in the same ratio, which means AD by DB and AE by EC will be same. Now let us see the converse of this theorem. Now let us see the converse of the theorem. The converse says if a line divides any two sides of a triangle in the same ratio, which means AD by DB equals to AE by EC, then this line is parallel to BC. Okay, see, if AD by DB equals to AE by EC, then D is parallel to BC. Let us prove it. Now, for proving what I'll do, I'll construct a line, suppose DF, in such a way that DF is parallel to BC. Okay? And if I can show that F and E coincide, our work is done. Pretty easy. Just look over here. I've taken DF parallel to BC, which means by basic proportionality theorem, AD by DE is equal to AF by FC. Okay, and this is already given to us, which means AD by DE is equal to AE by EC. This is given to us. So if you compare these two, we can say that AF by FC will be equal to AE by EC. Okay, by comparing, suppose this is 1 and this is 2. Now look carefully. What I'll do, I'll add 1 on both sides. I can do that, isn't it? So just look. If I add 1 and then take LCM, so this becomes AF plus FC is equal to AE plus EC by EC, isn't it? Now AF plus FC is nothing but AC. So AC by FC is equal to AE plus EC is again AC by EC, which clearly means if C equals to EC, FC equals to EC, which says that F and E coincides, isn't it? And F and E coincide, which means DE line is same as DF, which means if we have taken DF parallel to BC, simply means DE parallel to BC. Done. Clear? Now let us see one more theorem before we move to area of similar triangles. Now look at this theorem, which says that the internal bisector of the angle of a triangle, in this case AD is the internal bisector of angle A, divides the opposite sides internally in the ratio of the sides containing the angle, which means if AD is the bisector of angle A, then BD by DC is equal to AB by AC. That's the theorem. Let us prove this. Look what I'll do. I'll draw a line parallel to AD passing through C. Suppose this. And what I'll do, I'll join this. Okay? Suppose this is E. Okay? Now, CE, remember, is parallel to AD. So this angle and this angle will be alternate angle, isn't it? Because these two are parallel lines, which means angle DAE is equal to angle ACE, alternate angle. Just look carefully. What I'll do, my first thing is to prove ACE is an isosceles triangle. Now look carefully. This angle and this angle will be equal, corresponding angle, because AD and EC are parallel, and this angle are corresponding angle. They are equal, which means angle BAD is equal to AEC. That's corresponding angle, isn't it? No, this is angle 1, this is angle 2. Angle 1 and angle 2 are equal. Why? Because AD is the bisector of angle A, which simply means angle ACE is equal to angle AEC, which means AEC is an isosceles triangle, isn't it? Which means AC will be equal to A. Now we prove that this is a isosceles triangle. Now look at this triangle BCE. In triangle BCE, AD is parallel to EC, isn't it? So by basic proportionality theorem, BD by DC is equal to AB by AE, and we have already proved AE and AC are equal, which means BD by DC is equal to AB by AC, and that's the theorem, isn't it? We did a construction, we proved that this triangle is a isosceles triangle, and then by basic proportionality theorem we can prove this. Let us see the converse for this theorem now. Now let us see the converse of this theorem, which says that if a line through the vertex of a triangle divides the opposite side in the ratio of the other two sides, which means if AD divides BC in such a way that BD by DC is equal to AB by AC, then the line bisects the angle of the vertex, which means 1 and 2 are equal. AD bisects angle A. Let us prove this. What I'll do, same, I'll draw, suppose, a line EC parallel to AD, and I'll join A and E. So I'll get a triangle AEC. Okay, my main motive is to prove that ACE is a isosceles triangle. Our work will be done. Look carefully. First of all, AD is parallel to EC, which means by basic proportionality theorem, BD by DC, see, AD is parallel to EC. So I can say BD by DC is equal to BA, that's AB by AE, and already given that BD by DC is equal to AB by AC, which means if we equate 1 and 2, you can see carefully, AB by AE, AB by AE will be equal to AB by AC, which simply means AE equals to AC, which means this side and this side are equal. And if these two sides are equal of this triangle, we can say that this angle and this angle are equal. Angle ACE, angle ACE is equal to angle AEC. Suppose this is X, isn't it? Now look carefully. Angle 2 and X will be equal. Angle X equals to angle 2. Why? Alternate angle. And if you look carefully, angle 1 and angle X are equal because AD and EC are parallel, they are corresponding. Angle X equals to angle 1 corresponding, which simply says by these two, angle 1 and angle 2 are equal, which means AD bisects angle A. Simple. We just needed to prove that this is a isosceles triangle and a little bit of knowledge about parallel lines. Done. Now let us see how the areas of similar triangles are related to each other. Very important. Now look at the most important thing, areas of similar triangles. If two triangles are similar, the ratio of the areas will be equal to the square of the ratio of the corresponding side, which means area of ABC by area of PQR. If suppose triangle ABC is similar to triangle PQR, then the area of ABC by area of PQR will be AB by PQ whole square or AB square by PQ square, BC square by QR square, AC square by PR square. Let us prove this. Look carefully. What I'll do, area of triangle ABC, can I write by area of triangle PQR? Can I write this as half into base, that's BC, into height, that's AD, and over here half into base, that's QR, into PM, isn't it? This goes away, so this becomes BC by QR multiplied by AD by PM. Done. Now look carefully. Look at triangle ABD, triangle ABD, and triangle PQM. See, since ABC and PQR were similar, this angle and this angle are equal. This is 90 degree, this is also 90 degree, which means these two triangles will also be similar. I'm talking about ABD and PQM. They are similar by angle-angle property, which means triangle ABD is similar to triangle PQM, angle-angle property. Okay, isn't it? Angle-angle property. Now once they are similar, can I write AB by PQ is equal to AD by PM? AD by PM. Now look carefully. BC by QR into AD by PM. AD by PM I can write AB by PQ. Isn't it? Now, first of all, these two were similar triangles. So I can say AB by PQ is equal to BC by QR is equal to AC by PR, isn't it? So instead of BC by QR, I can put AB by PQ. So this becomes AB by PQ multiplied by AB by PQ, which is AB square by PQ square, isn't it? So the area of the triangle ABC by the area of triangle PQR is nothing but AB square by PQ square. Now we know this. AB by PQ is BC by QR, so it will be BC square by QR square will be equal to AC square by PR square. So this is one of the most important result. Okay, now based on this, areas of similar triangle, how they are related, there are some more results. I'll show you those results before moving to the exercise. Clear? Now these are also the results of areas of similar triangles. That is, the ratio of areas of two similar triangles, so suppose ABC and PQ are similar, is equal to the ratio of the squares of the corresponding altitude. So if AD is the altitude of ABC, okay, on BC of course, and PM is the altitude on QR from P, the area of triangle ABC by area of triangle PQR will be equal to the square of the altitude, AD square by PM square. Okay. Second result, which is important, the ratio of the areas of two similar triangles is equal to the ratio of the square of the corresponding median, which means if AD and PM are the medians. What are medians? AD divides BC into two equal half, that is BD and DC. QM and MR are same. In this case, if AD and PM are the corresponding medians, then area, the ratio of the area will be the square of the median, that is area of triangle ABC by PQR is equal to AD square by PM square. And the third one, the ratio of the areas of the two similar triangles is equal to the ratio of the squares of the corresponding internal angle bisector segment, which means suppose AD bisects angle A into two equal half and PM bisects angle P into two equal half. See, AD bisects angle A, PM bisects angle P. Then the ratio of the areas will be equal to AD square by PM square. Clear? So this was the entire explanation of this chapter. Everything is important. If you know all this, it will be very easy to solve sums. Keep it till here in this video. In the next video, we'll start with the exercise. Till then, take care.